Thank you. Thank you. Thank you for the introduction. Thank you, ACM IEEE, for coming to TCNJ. I hope this is the first from a longer series. Maybe we can get to a point where we can alternate between Princeton and TCNJ. But for that, I have to encourage you, TCNJ students. Thank you for coming. And as you heard, the whole point. They roped me into giving this talk too, but the whole point is to really expand membership, and since they're the local ACM professional chapter, what better way to expand membership than to look at the ACM chapters at nearby colleges? So that's so thank you all for coming, and please consider checking their monthly events. I think Josephine added ACM to the our ACM TCNJ to the mailing list. So hopefully somebody's getting those emails. If not, I can forward them to the ACM membership. It's every third Thursday in a month, right? Thursday, the third Thursday,
Yes.
the third Thursday of every month. There's a talk. There's some introductory remarks as you saw, listing of activities. There's always the part about the jobs, which I love. And then there's some talk. So some students, not none of you, I don't think, but when I teach computer graphics, and that usually happens every other fall, I usually give extra credit for the SIGGRAPH show, which the Princeton ACM has, which is basically a presentation of the coolest videos that were shown that summer at the SIGGRAPH Computer Graphics Conference. So that's always a fun topic to tie into our graphics class. All right. So again, basically the idea is that please continue to keep an eye on Princeton ACM and join their meetings, and then hopefully you'll become involved with all those like you and bring a friend, and somebody will help Josephine out with all the things that she was asking for. Okay, so I'm going to talk about one of my research projects today, and that is analyzing and generating conducting gestures using computers. And so I'll give a history of how I got to this project, or rather, what else is happening in this area, and then I'll get to some of my most recent results. So this whole presentation, I should make sure that the volume is not too high before I move on to the next slide. Let's see. Here we go. Let's see. How loud is this going to be? Oh no. This is what happens with YouTube. There we go. All right. So musical conducting. Some of us are familiar with it. Some people maybe have never seen a conductor in action. You've seen a conductor if you've ever seen a classical concert, right? So a symphonic concert, or opera, or rather the orchestra and the opera, or choir, right? Or marching bands have conductors. Not always that popular anymore. I think the music that requires conductors these days is definitely not the mainstream music that most of us listen to on a regular basis. Now, classical music or choirs or marching bands would not be what they are without a conductor. And I'm going to date myself here, but those of you who are my age or older probably grew up knowing about Leonard Bernstein, maybe watching his shows popularizing classical music and explaining what the orchestra looked like and what conductors did. So that's why I put him up here. One of the really most famous conductors of all time. Another reason why I chose this particular clip of Bernstein conducting Mahler is that if you saw, has anybody seen the film Maestro? Yes, okay, at least one person. All right. So Bradley Cooper played Leonard Bernstein, and he actually played exactly this scene. He was pretty good at copying what Bernstein was doing. I guess this video moved away, so I'm gonna scroll back here. So what does a conductor do? Why is he important, or why is he or she important? What are we looking at? Well, for the musicians, the conductor is very important because it keeps the orchestra or the choir in sync, synchronized, making sure that everybody follows the same tempo, everybody is at the right volume. They start right, different instruments are going to start at different times, and then they have to take a rest depending on the music, and the conductor is there to keep everything in sync. One reason why so many of us are fascinated about conductors is the way they do this. And the act of conducting is an act of communication and also an act of artistry, right? So they communicate the music. They also contribute to the music that is being played, right? The same sheet music can be played in various ways, and that depends on the conductor. So conductors like Bernstein really influenced the way in which music sounded, right? It didn't sound just like the way it was on paper. The conductor contributes to how it's played. So how does this communication happen? I think the first thing that we notice, and the first thing when we think about conductors, is they kind of do this, right? This is all they do, right? And this is what we're mostly familiar with. And okay, so this is not the gesture, and we'll talk a little bit about the gestures that conductors do. It's a lot of arm gesturing. It's not just that, and again, I'm going to pull this back. You probably noticed with Bernstein going in the background there that there's a lot of facial gesturing as well, a lot of communication going through that. And then if you're a music lover who just likes to go to concerts, you will probably watch the conductor a lot, just to enjoy that show that comes sometimes from the conductor, just feeling that music. Now, ultimately, if we go back, yes, this is part of the show, but at the core of it, conducting is the communication of there's some tempo that you all need to follow, and now it's your turn, you come in and you need to slow down and things like that. And so if you're on a college campus, then this is not the type of conducting that you can see on an everyday basis, but more commonly on a college campus, you will see something like this, because students, music majors especially, learn at some point where in college to conduct. And when they learn, they're not going to look like Bernstein, conducting 1 and conducting 2. Don't deliver performances like Leonard Bernstein's. it's more of a clear gesturing. So if you look at these student conductors, you'll actually see that the communication maybe is actually more clearer. You can maybe recognize some of the gestures, and they're more textbook, right? Than what Bernstein was doing. So again, what does a conductor do? Well, first and foremost, the conductor needs to show the musicians the tempo, keep track of the tempo, and the conductor will do that following the time signature, which you may have heard of. It's maybe a 2/4, a 3/4, or 4/4 are the most common time signatures. Basically, how many beats are there in a measure, right? That's what the time signature will tell us. And then the tempo, that's what you see, that rhythmic motion that the conductor does, right? That's the beat, right? The tempo of the music, how fast or how slow the music should be played. In addition to that, I mentioned cueing, entrance cues. When is a specific instrument or a specific singer's turn? The conductor will cue that. Or dynamic cues, play louder or softer, or a little faster, or a little slower, right? And that's it, right? Easy. Well, it's not easy again because you saw the big difference, but you have to start somewhere. And if you look at the beginning, at the first chapter of a conducting textbook, this is basically what you see, and this may be somewhat easy. This is still hard because it turns out that keeping track of all that stuff in your head, what is the tempo? And you don't have a metronome playing the tempo for you. You need to keep that in your head. And if the musicians veer off, you need to realize, oh no, you're going too slow. You need to speed up, right? So it's a little it's a little harder. But for a long time, as long as people have been fascinated by music, and then computers came along, and AI came along, and people started being fascinated by combining music with computers, right? And so I'm specifically interested in this case in combining computers and conducting. So what do they have in common? How can you bring computers into this equation? Well, you could allow humans to conduct a virtual orchestra. So basically, open up conducting to everybody through maybe a video game that has a virtual orchestra where anybody could try their hand at conducting and having that orchestra react to them. Or you could do the opposite. You could have virtual conductors, robotic conductors, conducting a human orchestra. Why would you do that? I don't know, for fun, really. Ultimately, there's obviously some fun in that. The first thing that I will say, and I will repeat every time I get the chance, we're definitely not doing the second point here, where the virtual conductors. The point is not to replace a human conductor. We cannot reproduce what a human can do, right? Just like now, these days we're talking about how we don't want AI to write our books and create our movies. We also don't want AI to play our music. So then what's the application that remains? Actually, education is a very good application for this. You could use a system like you could use a computer to augment the musical performance, where we were mesmerized by Leonard Bernstein, but sometimes in these days when it's never enough and we need more and more stimuli to be entertained, maybe we can build on top of what a conductor does, build some sort of an animation, some other effects that really emphasize the music. Or what I've been doing lately with my students, work on systems that provide feedback to beginner conductors, have a conducting tutor. So where did this all start? I started collaborating with when I joined TCNJ, very long time ago at this point, almost 20 years ago. I started a collaboration with Dr. Teresa Nakra, who had also joined TCNJ around the same time. And this is an initial work that she did for her PhD thesis. She basically did the first steps for this idea that I said of humans conducting a virtual orchestra. So you have some way to communicate with the music that is playing on a computer, and you can make it faster or slower. Let's take a look.
I adjust the bass voices with my right arm and the treble voices, violins and flutes with my left. I'll just give you a short example of an extreme performance where I take things really fast and slow, and then following that I'll do a full performance of super. And now it's complete. Now it should, if I slow down, it should slow down with me. And it may take a little bit of time. So now it's very fast. And now if I relax it, and slow down. You hear that?
So what's really awesome about this is if you notice that the music was speeding up and slowing down, and if you try to speed up music on your computer, then you'll notice that the pitch changes, and it's that weird, really high pitched thing going really fast. So she actually developed an algorithm that speeds up the music without messing with the pitch, and that's why she was able to do this. And so building on that, then she built an actual exhibit at the Boston Children's Museum, which was there for a few years, where children were in this setup where they could actually conduct a virtual orchestra. That it was a recording that was on the screen that they could manipulate. They would manipulate the audio and maybe the speed of the video a little bit as well. So at some point, I think this also turned into a video game. I think maybe the Wii had something had a game along these lines. So you could do that. All right, so that's humans conducting virtual orchestras. There's virtual conductors conducting human orchestras, and the fascination with this, the fascination with this initially was really just a feat of engineering. So some of you may be familiar with Honda, with the ACM robot built by Honda. And so this is Honda's ACM conducting an orchestra in Detroit. Yeah, you have to watch the intro for this too, because but here we go. Yes. the audio is not that loud here. So this may look like a feat of engineering until I tell you that, yeah, sure, this is in fact really cool that you can have a humanoid robot that has this range of motion. There's no intelligence here, however. There's no intelligence whatsoever. This whole thing is pre-recorded. So I was told by musicians, I don't really have a good musical ear, but if you pay close attention to this, you can see that at some point the musicians are completely off, like the tempo is not synced up anymore, and there's no feedback. There's absolutely no reaction. How did this work? Well, apparently it wasn't even a conductor that they recorded, because a conductor would not stoop themselves to that. It was somebody in the PR office of the orchestra who said, "Okay, I can do this. You guys record me, and then teach the robot how to do this." So it looked good until you learned about the details. And what was it? It was again a feat of engineering, because from a mechanical engineering standpoint, this is still awesome. All right, this is much more recent. This is from last year, and I guess we have to. Interestingly, I never got ads when I tried this at home. There we go. Couple more seconds. Oh, of course. There we go.
The Princeton Symphony Orchestra presented an innovative world premiere on Saturday. Instead of a flesh and bone individual conducting the performance, 3 robotic arms guided the musicians as they played a bespoke piece titled Robot Symphony.
Wir wollen keinen Dirigenten ersetzen. Ich glaube nämlich daran, dass ein Mensch es auf jeden Fall immer besser machen kann. Die Probenarbeit, die Mimik. Wenn man jetzt zum Beispiel, nehmen wir mal an, mit Beethoven spielen würde, das braucht man mit so einem Roboter nicht. Das ist sinnlos. Ne? Aber wenn man jetzt ein Stück schreiben lässt, was daraus Kapital schlägt, dass das Orchester in verschiedenen Geschwindigkeiten spielt, in verschiedenen Taktarten, dann macht es Sinn. Das gibt es auf der ganzen Welt nicht.
The East German Musical Institution celebrated its 25-year anniversary by looking into the future. The Dresden Symphony Orchestra is known for pushing boundaries, which this time even challenged its musicians.
Das ist ganz anderes. Es ist halt auch ohne Gnade. Also es wartet auf niemand, es zieht durch.
Attendees of the debut performance lauded the innovation, with others stating the piece, riddled with multiple time signatures, sounded like it came from a single source.
Right. So this is another way to justify this, right? It's something that a human conductor couldn't do. 3 arms, all 3 arms were conducting in a different tempo, in different time signatures. And even the musicians were confused and probably needed tunnel vision to just really focus on their own, and probably the overall sound was better. All right, so inspired by ACM, the first recording there, 15 years ago at this point, we actually had a class here at TCNJ where our students built conducting robots. And we wanted to do better than ACM. We did not allow pre-recorded things because there's really no computer science happening in that. You just copy the movement, it's engineering. What we wanted to do is that we wanted to, the ultimate goal again was to bring students together and have them build something. The application was educational, but what we wanted to do was to build a robot that can conduct from sheet music, not a pre-programmed routine. And so for that, we had a class in which we brought together students from 4 majors. We had music, mechanical engineering, computer science, and IMM, interactive multimedia. We had 4 professors teaching that class. I was the computer science one. And in one semester, they managed to build this. Now, we provided sheet music. What? How does that happen? How do you get a robot to teach sheet music? Well, you need digital sheet music. And so what is that? How do you get digital sheet music? Well, the easy way, the older way is MIDI. I see some of you nodding. MIDI is an older by now technology, older than our computer technology that we use today, that is used to synchronize electronic instruments. So you all may have heard of MIDI keyboards, right? And so they communicate with each other and they sync up through music that is encoded in MIDI. And so what you see in a MIDI file is basically all the music is encoded with, okay, note on, this is the frequency for this time, okay, note off, okay, then the next note, and so on. Very different from what we have in sheet music, and it also misses some of the good stuff that conductors might use from the sheet music. So more recent, what we use later, and I'll get to the application of that, but now we have music XML, which is an XML notation. You're all familiar with that probably. XML notation, specific for music. Again, all the notes are encoded there, their duration, the tempo is there, all the beats, all the cues, everything that you need. And there's software that will convert back and forth between sheet music or you'll give it the music XML and you get the actual music notation. These are some of the tags that you'll see in the music XML, and some of these, in some weird ways, also show up in the MIDI files. So we used MIDI files 15 years ago. Music XML has become more common since then, and there's more music available written in the music XML notation, but 15 years ago we stuck with MIDI, and here are some of the constructions, some of the contraptions, I should say, the robots that our students built. This is on stage in Mayo. They tried to pick music that sometimes worked with the design. Now, some of the robots were more or less humanoid. Right? There's arms there that are definitely doing the tempo and the pattern. You can, in this case, you can see those LED lights are also showing the beats and the pattern. Let's see, I have more. One thing that the students looked at is what other cues might conductors use, and our musicians and music majors told us that, you know what, the breathing, when the conductor inhales, that means a lot to me. I can see that they bring everything together that way. So then our engineer students had this lovely idea of simulating the breathing there with that little thing that goes in and out under the shirt. Other students told us, well, you know, really the facial expression means a lot to us. So it's like you bring us a faceless computer, it's not the same. So one group of students came up with this. I don't know, for my students who were there for our Uncanny Valley discussions last semester. That's right there. This one, if you listen, and if I were to bring up the volume, you can also hear some squeaking of those servos that are moving the arm, because obviously we can't afford the Honda quality motors, so like ACM, so we had some of that. Here's another one that was a little friendlier with that, just a constant smile there. Notice how Autumn is making sure that the laptop does not, and the head therefore does not fall off. You know, there were little kinks, but please remember that these were robots that our students built from scratch in one semester. Not everybody went with humanoid. It's like this was a struggle where they decided, well, this is kind of like a clock, and this is one measure goes like this. Maybe you want the conductor to have a nice shirt and tie for some reason, so we can still have that, but it's not humanoid at all. All kinds of challenges here as well, because if you want to do something that moves vertically like this, you need to account for gravity. So coming down is going to be faster than going up. So all kinds of challenges, but we were able to generate, students were able to come up with motion based on music that they read from a MIDI file, and they figured out what that pattern needs to be, whatever they translated it into. We redid this a couple years ago. Well, a couple actually. This was literally as COVID was sending us into isolation. Let's see if I can. There we go. This is just an animation that one of my students did. Now this one has more, right? Because she wasn't limited by robot and mechanical capabilities. This actually has cueing, so you'll see you'll see these colors come on and turn off depending on which instruments should be playing. So you saw initially the clarinet was black here. Right, let's try this again, right? So as they all come in, and then the clarinet goes out, and then the triangles, they are down or up. There, the clarinet and the cello are out. Now the clarinet comes back in. Meanwhile, this is showing the tempo going through a 3/4 measure. This was done not from a MIDI, but from a music XML, so there was a lot more information there. All right, so that's some of the history that we've been through, and so we did a lot of, okay, we can build things that conduct, but originally my research area has always been computer vision. And so I was always interested in looking at the conductor's motion and analyzing what they do. So can we have, right, the first example that we saw, can we have a human conduct a virtual orchestra? Or even better, what's the point of a virtual orchestra after all? But working with my colleagues in the music department, it turned out that it would be very helpful if we came up with a tool that provides feedback to the conductor, and more specifically to a student that is learning how to conduct. Because when a student learns to conduct and they take these conducting 1 and conducting 2, how do they practice? When you play an instrument, you practice with your own instrument and you can tell right away, oh wait, this doesn't sound the way I expected it to sound. But when you practice conducting, often in front of a mirror as they do, you don't have feedback. So you don't know. You can practice in front of a mirror and you can see things maybe, or you can record yourself and give yourself some feedback. But truly the best feedback you have if you do it in class, you have an orchestra there or you have your professor there and they give you some feedback. So we want a computer to watch a recording or a live performance of a conductor and give some feedback. Like what? Well, don't dance around, or rather not necessarily dance, but you know, If you just lean in various ways, then you're confusing the musicians. Don't mirror too much, because I say conductor, I'm not a musician, I'll go like this. But that's not, you're not supposed to do that. In most cases, you should not do that. So don't do that. Keep the correct tempo. What my musician professor colleagues told me was that somehow when a student is up there and gets in the zone, sometimes they can't tell what the time is. They think that they're doing the correct tempo, but actually they're not. So somebody needs to give it to them and needs to correct them, and also keep the correct time signature. So there's different gestures for different time signatures. So basically what we're looking for is, and this is an output that we're getting these days, where every time there's a beat, the computer will tell us, yep, you just conducted the beat. Here's the current BPM is 61. And by the way, right now you're mirroring, right? Now, how can we do this? We need the computer to figure out the pose. Where are the person's arms? And that's a hard thing to do. If you've been watching, if you've been reading about motion capture, then you know that this is actually a pretty hard problem. And until recently, you would have to wear various costumes or do the motion in front of a green screen or a blue screen so that they can track you really well. Or you can use 3D cameras. So we actually did this initially with the Microsoft Kinect camera that gave us depth, and it could easily track the skeleton, the human body. In general, you need more complicated devices that are sometimes hindering the conductor's motion. So these days, though, thanks to machine learning, we now have very good pose detection on just regular video that you can get with a webcam or a phone camera, or even video that you can get off of YouTube. So, and this was developed by Google. Google has this package called MediaPipe. You can program it in Python, for example, other languages as well. And so basically what this does is that it gives the skeleton, right, the outline and the joints of any person that is in the video. So basically something like this, it gives, for every frame in the video, it gives coordinates for all these points. And ultimately, if you think about it, this is all we need for conducting. We need to see where the arms are, right? So we use this system, which now works in Google MediaPipe works in real time, and it works on any video. We use it for conducting pose detection. So if you get a picture of a conductor, and this is our awesome New Jersey Symphony conductor, somewhat local to the state of New Jersey conductor,
and she's quite small.
Yeah.
And she jumps up in the air.
she really is awesome. And whatever recording you find of her, you can do pose detection with Google MediaPipe. And initially I figured maybe I should find another picture, but I actually realized that this is great. You can see that, well, you can't see her legs. And MediaPipe did its best guess as to where her legs are. It doesn't matter. It doesn't matter. We don't care about the legs for conducting. The arms work perfectly well. The face is there too. That's all we need. So if we have this, what do we need? We need arms and shoulders. Ultimately, this is all that we need right now for our system. And so the first thing that we said was, well, remember what it was? We said, don't dance around. Don't jump around. I know she does. But when you learn how to conduct, you don't do that yet, right? So So this is what makes maybe our problem a little easier, that beginner students are really required to follow some gestures that as they are described in their textbook. So they're not jumping around. They shouldn't be swaying as they conduct, because that is confusing. So how can you find swaying? Well, in general, now that we have coordinates, we know exactly where all these joints are at any point in time. What we can do is track them over time and see how they move. And if you do this correctly, your shoulders should not be moving, or the center point between your shoulders, the middle of or the top of your chest here, should not be moving. You should be conducting like this. So we can use those coordinates and check. And we zoomed in here a lot. This would be right a perfect motionless conductor, a robotic conductor, which we don't have. Obviously, we have humans, we have students. There's a little bit of motion. This is very, very little, very much zoomed in. This is the threshold. We say, okay, if you go past that, then you're swaying. So this student, however, this student was going a little bit like, oh yeah, I'm sort of conducting, but also following the music, which you shouldn't be doing. And this is just an easy graph, and then with an easy algorithm, we can pick this up. Oh wait, you're a little too far from where you should be. So you're swaying. Please stop swaying. Mirroring. Again, your hands should be doing different things. So if we look at both hands, this is at this point just the x coordinate, right? We're also obviously looking at the y coordinate of the hands. What is mirroring? The y coordinate is always the same, and the x coordinate, right? The two hands are mirroring each other. They're symmetrical. So if you draw a line in the middle, they're moving away from that line of symmetry or coming back close. So sure enough, if you look at the red and blue lines here, the right hand and the left hand, the x coordinates of the left and right hand, you can see already that they're mirrors of each other. And so what I have in the middle here in black, it's the center of the chest, the coordinate. I took the midpoint from between the shoulders. And then what we have in green, we just averaged the hands, and you see they're kind of the same. So again, well, you're mirroring, you shouldn't be doing that. Here's another video where, no, this person is not mirroring. Look at that, their left hand is barely moving. Here they might say things that, oh, okay, here you start some cueing, and the right hand is following the beat. So overall, right, the midpoint between the hands, the green obviously mostly follows the blue, and it's very far from the constant center of chest, which is not moving. So these are easy, right? These were indeed easy, as my students know. These were the first things that they implemented. That's easy. What's harder? Harder might be to find the beat. How do you find the beat? Well, first, in order to find the beat, we want to look at what are the actual gestures. So the 3/4, the 2/4, 3/4, or 4/4 tempo or pattern that conductors conduct, right? So if it's a 2/4, we're gonna go 1, 2, 1, 2. If it's a 3/4, they're gonna go 1, 2, 3. 1, 2, 3, and if it's a 4/4, then they go 1, 2, 3, 4, right? So sort of like that. So there's a lot of motion there. How do you figure out where and when does the beat happen? Well, it turns out that it's always a downward movement, and these images that I have here on the screen, this is actually a screenshot from the textbook. And so where these numbers are, that's the beat number 1, beat number 2. You see there's always a downward motion. So you can pick that up. And so if you plot the y coordinate, I also have the x coordinate here. But if you plot the y coordinate of the right hand over time, you see that that the y coordinate goes up and down. Sure, in the meantime, it will go left and right too, but there's always a sort of a bounce, a little bounce when that beat happens. So 1, 2, 3, 1, 2, 3. And so this is what we see. I'll tell you in a minute what those red dots are. What we're looking for here are the valleys in this plot, not the peaks right now. It's the valleys, because that's when it goes down. So we put these dashed lines here to mark the beats. So this is how we mark a beat, and then obviously you have this in a video, you can count and you can see, okay, what's the tempo? Now that I know where the beats happen, just visually, I can tell you the tempo. Okay, now we need a time signature as well. What's the time signature? Ultimately, the time signature is how many beats happen in one measure. And one measure always starts from up here, right? So it's 1, 2, 3, for example, 1, 2, 3, and you always come back up. So then what we looked for were the peaks in the plot of the y coordinates, because the peaks sort of, if I go back here, the peaks of the y coordinates, so the high points here, show where that whole beat pattern ends. So beat 1, yes, the beat is actually on the down peak in the valley here, but it is between two peaks, and then it comes down again for 2. And the same thing happens for the other patterns as well. So what we have here, right, it's going to be the first beat, which always starts up here, right? It's always the highest one, and then there's 2 more, 1, and then there's 2, 3, right? The other 2 peaks, and then back up again, and so on. So we find the highest peaks, and we see how far apart are they. So there's 2 more peaks between the highest ones, right? There's high, 2 more, high, 2 more. So that means it's a 3, 4, right? And now here's the thing. We found this. Remember, what do we do this for? We teach students. Now the students, sometimes, especially if your class is in the morning, who wants to conduct in the morning? And you go there and you're like, yeah, like that. Sometimes conductors, professional conductors will do that too, just like that. Well, I'm sorry, if you're taking conducting 1 or 2, you need to have the energy and show the thing. So it's not enough to just have the beat. You need to follow the pattern. So we'll find the beat usually, and if the students do the pattern correctly, then if we plot, what we have here is x versus y coordinates. So what are these? These points correspond to the peaks over here. They correspond to the endpoints. If you were to conduct in a triangle, right, 1, 2, 3, that's what those dots correspond to in our graph, right? So when you conduct, your pattern should always be the same. Don't just go like this and yeah, oh, okay, I just remembered, okay, I need to go big. Okay, I'm tired. I go, no, wait, I need to go big. Wait, and now for some reason I moved out here, right? That would be bad. I don't have an example of the bad one. I have an example of the good one. Usually you always want, right, those points. So this is in a 3, 4, these points need to be clustered in those 3 clusters. And so where does this take us? It takes us to a final output. Let's see if we have this. There's our output. We now have a video that tells us exactly when the beat happens. We get the BPM up here, which varies sometimes. You see how some swing is happening. We also have rocking. We said rocking for back and forth motion and swaying for side to side motion. And some mirroring is happening sometimes, and sometimes that's okay, right? So okay, you're mirroring now, and then at some point he stopped a little bit, and then he's mirroring again. So this is what we have. And the great thing about this is that we can do this on any recording. So what I have here is something that we got from a conducting class, but we can also try it on any video that we scrape off YouTube or anything. So this is where we are. We want to continue. We want to add more patterns. We want to look at additional features. We want to start looking at cueing. Let's start looking at what the left hand is supposed to do something else. Then let's do that. We also want to give some real-time feedback. Right now, we need to look at the entire video to make sure that our tempo calculations are correct. So we need to look into doing that in real time. So this is where we are, and our work continues. I didn't do this alone at all. I started with my former colleague Teresa Nakra, who was here at TCNJ until this fall, and she's now at Stevens. My colleagues Chris Alt from IMM, or rather the Design and Creative Technologies, Yunfeng Wang from Mechanical Engineering, and David Vickerman, who is my conductor friend, who was a professor here, and he is now at San Jose State University in California. He's a band conductor there. Again, so they helped with the ideas. The implementation came from my former students. Some of their names are listed here. Some worked on this individually, and then there's the students who took conducting robots about 15 years ago, and I think one of them is on Zoom listening. If she's still there, she was there in the beginning. Thank you. And of course, a huge thank you to my current students, Leila and Jeffrey. Thanks for coming tonight, and thanks for your good work. And thank you everyone for coming. I'll take any questions.